All right, well, good morning. Or actually, I guess it's good afternoon.
Yeah.
Really, there's somebody working in the shop?
Yeah.
All right, can you guys hear me in the back?
Yeah.
All right, okay. My name is Rick Maurice. I'm with Capital Safety. We're manufacturers of a lot of the fall protection equipment that you guys are currently using. And I'm here to talk to you about fall protection. Now, by show of hands, how many of you have seen this presentation before? Okay, a fair number of you. For those of you, it'll be a review. For those of you that have not, it'll be brand new stuff. For those of you that have seen this, there's some new equipment, new regulations, and we're going to talk about those. Now, before we get started, the first thing that most people tend to think about when we talk about fall protection is active fall arrest systems. Harnesses, lanyards, self-retracting lifelines. Honestly, it's the last thing that we want you to think about. What we want you to do first and foremost is to do your job hazard analysis. During that job hazard analysis, we want you to identify existing or predictable hazards. Once identified, there's one of 4 different things that we want you to do with those hazards. Number 1, primary objective is hazard elimination. Get rid of the hazard. If you get rid of the hazard, problem solved. No need to take any further corrective action. But if you can't get rid of the hazard, the next thing we try and do is restrict access to the hazard. Now, we're restricting access could be warning line systems, guardrail systems, lockout, tagout, fencing, netting. Anything that prevents me from accessing that hazard is ideal. But sometimes that's not always possible. So if we can't eliminate the hazard, we can't prevent access to it, the next thing we try is an engineering control. Now, an engineering control can be something as simple as moving a valve or an electrical box down to ground level, or something as complicated as auditoriums, for instance. A lot of your auditoriums have light stages that are on winches. When the electrician needs to do maintenance, flips a switch, that light stage comes down to ground level. The electrician does all the maintenance right at ground level, went through, flips a switch, that light stage goes back up into place. That's a great example of engineering out the hazard. Why? Because you didn't have to expose that worker to a potential lethal fall. But sometimes that's not always possible. So if you can't eliminate the hazard, you can't restrict access to it, and you can't engineer it out, then the last thing you're left with is personal protective equipment. In my world, it's personal fall arrest equipment. Why is this the last thing that we want you to utilize? Because there is a potential for a mess up, right? The other reason too, it restricts mobility, it adds weight, and most importantly, there's responsibility that goes along with this gear. For instance, you gotta know, how long are these harnesses good for? How many falls are they good for? Can you wash these harnesses? Can you ride on these harnesses? Who has to inspect this stuff? Does a competent person have to do it? Does an authorized person have to do it? Does a qualified person have to do it? Are there definitions for all those people? Your anchor points, what are they rated for? 5,000 pounds, 10,000 pounds, 15,000 pounds? Can they be rated to less than 5,000 pounds and still be legal for fall arrest? There's a lot of information that goes along with this gear, and we're just going to scratch the surface here this afternoon. So, who can tell me what the number 1 rule in fall protection is? That's rule number 2. What's rule number 1? What's that? You're fired once you hit the ground. No, that's not the number 1 rule. Actually, the number 1 rule in fall protection is don't hit the ground. Kind of a smart aleck answer, but if you think about it, it's true. If you're working at heights and you're paying attention to what you're doing, and you've got your gear rigged so that you don't contact the lower level, then you're working safely at heights. Now all you have to do is control your free fall distance. So the number 1 objective is if you never ever want to hit the structure below or swing into another object. Either one of those is equally as bad. All right, when you're working at heights, your fall arrest system has 4 components to it, and they're easy to remember. A, B, C, and D. A stands for anchor point, B, body harness, C, connector, and lastly, D, descent and rescue. So let's start out with A, anchor points. Everything that you tie off to for fall arrest has to be rated to how many pounds?
5,000.
5,000. And that's 5,000 pounds per person attached, right? 2 people, 10,000, 3 people, 15,000. The math is pretty simple. Now, can an anchor point be rated to less than 5,000 pounds and still be legal for fall arrest? Yes, it can. For instance, a lot of us manufacturers make anchor points that are rated to less than 5,000 pounds because oftentimes we find ourselves trying to attach to structures where the substrates won't meet the 5,000 pound intended load requirement. Any of you work out of the Genies, JLGs, extendable lifts? Most all of you have, right? Do you have to tie off in those devices? Absolutely. Anything that booms out, extends out, or articulates, you have to tie off in those devices. You don't have a choice. Now, typically those anchor points are right at the mid-rail, right by the control console. and those are not 5,000 pound rated anchor points. If they were 5,000 pound rated anchor points, then that would imply that you could extend that boom out, reach out, pick up an ecology block weighing 5,000 pounds and move it around this campus. You couldn't do that, right? Why? Because you'd tip over the unit. We also make anchor points that are not rated to 5,000 pounds. How do we get away with that? Well, the standards do allow us to design, test, and engineer, keyword engineer, anchorages that are rated to less than 5,000 pounds, so long as we maintain certain safety factors. And the minimum safety factor that we have to maintain is a safety factor of 2. In other words, we have to backwards engineer that anchor point to meet twice the potential impact load. So just be aware that on occasion, you may come across anchorages that are rated to less than 5,000 pounds, but yet are still legal for fall arrest. But as a whole, everything that you tie off to, 5,000 pounds, and I'll show you some examples. Most of us manufacturers make anchor points for wood, for steel, for concrete, temporary anchor points, reusable anchor points, disposable anchor points, and these are just some examples. This is an I-beam anchor. This will go on top of an I-beam or on the bottom of an I-beam. All you do is ratchet the end pieces together like so. It's designed to move back and forth with you. It's a 5,000 pound rated anchor point. This is a column anchor point, so this one will bind. So this will grip the column so you can go vertically or horizontally. The only thing is it's not going to move with you. It's a 5,000 pound rated anchor point. Some technology that we borrowed from the rock climbing industry. This is a concrete wedge anchor. So this gets inserted into a hole into the concrete, set it, 5,000 pound rated. To remove it, pull on the blue tab, use it elsewhere. This is a toggle anchor point. This is designed to go through a hole in the steel, toggles into place, 5,000 pound rated. It can be loaded in any direction. Again, 5,000 pounds. This is a really common anchor point. They're known as tie-off adapters, cross-arm straps, chokers. However, what we don't call these lifting slings. Lifting slings and tie-off adapters are two totally separate devices. Now, could you use a lifting sling to tie off to for fall arrest? Would it work? Yeah, it probably would work. The only thing is that now, according to the state of Washington, if you can use a lifting sling, it can never be used for rigging again. It's got to be brand new, and it's got to be labeled as such. So it's not interchangeable. The problem is that Washington State, where they fail to realize there's a problem, is that what does that manufacturer say about their lifting sling? Are they going to let you use it for personnel? Probably not. Why? Because their testing, engineering, and most importantly, their insurance is for material handling, right? Vice versa with us. Our testing, engineering, and most importantly, our insurance is for personnel. So keep your rigging gear separate from your fall arrest gear. Now these are pretty simple devices. Small D-ring goes through the big D-ring, and you choke it up. If the strap is too long, not a problem. Go around again, just make sure at the last pass is a small D-ring going through the big D-ring. Now these are all examples of 5,000 pound rated anchor points. Now the structure that you attach them to also has to be rated to 5,000 pounds. So how do you know what you're attaching to is able to support a 5,000 pound load? You don't, right? So the mental picture that we like to give you is imagine that structure, whatever you're tying off to, being able to support the weight of your full-size pickup truck. If you don't think it'll support it, then don't tie off to it. So who can give you some examples of things that you probably should not tie off to?
Gutters.
Gutters, yep, absolutely not. For those of you that are taking down your Christmas lights, gutters are not approved. Again, the structure that you're tying off to has to be able to support the weight of your full-size pickup truck. If you don't think it'll support it, then don't tie off to it. Any questions on anchor points? Okay, let's move on to B, body harnesses. What are you supposed to do with your harness prior to putting it on?
Inspect it.
Inspect it, right? So we're looking for things like cuts, burns, frays, chemical burns, UV degradation. Check the stitching, check the webbing. Now when you're checking the webbing, you want to do a visual inspection as well as a tactile inspection. You want to touch the web. Reason being is your hands will pick up things that your eyes tend to overlook. Now the other thing you want to look for, you guys work in a shipyard. This is one I pulled right out of your shop. Cuts, burns, frays, chemical burns. Does this harness pass inspection?
No.
Absolutely not. This is not rated for working around welding or cutting or torching. Any kind of hot work, these devices are not designed for that. So whoever had this just ruined a $180, $220 harness. So that's no good. Again, you're looking for cuts, burns, chemical burns. Check the hardware, make sure it's free from rust, pitting, or corrosion. Check the impact indicators. By law, all harnesses have to have an impact indicator. So what happens is during a fall, this stitch will rip out, exposing the broken strands, letting you know that it was subjected to a fall, which, by the way, how many falls are these good for? One and only one. What do you do with one of these harnesses after you take a fall in it? Well, go home and do some laundry first, right? And then you're going to take it out of service. And if it's one of my harnesses, get a hold of me, get me a copy of the incident report, and I'll replace it for you. We actually have a harness replacement policy. Check the connecting hardware. A lot of us manufacturers use different types of connecting hardware. So we'll use tongue buckle leg straps, or pass-through buckles, or the new style, which are like connecting buckles, sort of like seat belts. Make sure that those are functioning correctly. Now, for those of you that are doing a lot of welding, a lot of hot work, make sure that you're using devices that are designed for that. This harness, for instance, is a Kevlar Nomex blended product. So this is designed to stand up to hot work. So welding slag will hit the web and it'll bounce right off of it. It doesn't burn. Other things that we look for when inspecting harnesses, labels. Labels have to be there, labels have to be legible. Now, what are some of the things you think you want to see on that label?
Inspection.
Okay, you want to see inspection. Now, by law, believe it or not, we don't have to put an inspection tag on there, but all of us manufacturers do it anyway. It's a good idea. So yes, that's a good thing to see. What else do you want to see?
Load rating.
Capacity. What's the max a person can weigh and be in one of these harnesses?
350.
Anything that's tested to meet the latest ANSI standard has a maximum working load of 310 pounds. Now that's 310 pounds, tools and all. Now we realize that we're getting taller and we're getting larger, so we actually do have a family of products that are actually tested to higher capacities. Now the thing to keep in mind is for individuals that exceed 310 pounds, it's A, B, C, and D. What did D stand for? Descent and rescue. You've got to be able to provide rescue for every member of your team. Rescuing somebody like me, fairly easy to do. Rescuing somebody that exceeds 310, a little bit more of a challenge, and pulling out your pocket knife and cutting the line is not considered to be an appropriate form of rescue, right? So you need to take that into consideration. The other thing you'll want to see too are standards that they've been tested to and data manufacturer. Data manufacturer has to be there. Other things you want to see on the label, who made it? Why do you want to know who made it? So you know who to sue, right? Absolutely. But the other reason you want to know who made it is, let's say for instance, you're working around chemicals, or you're working around electricity, or you're doing a lot of welding, or a lot of cutting and grinding, or you're working in unsanitary environments. We have many different types of materials that'll stand up better to those types of environments. That way we can better match the product to the type of work that you're doing, therefore maximizing your company's investment. What if your harness gets dirty? Can you wash it? Yes, you can. Mild soap and water, hang them up to dry in a cool, dry place, away from direct sunlight. Clean harnesses will last you a lot longer than dirty harnesses. What's mild soap? Basically, any detergent you can find at a grocery store is considered to be mild soap. What about writing on these harnesses? Can you write on them? Well, we did some testing. Why? Because you guys keep writing on your harnesses. Well, come to find out that the chemicals in Sharpie pens don't affect the webbing. So if it's a quick drying ink, that's fine. So your Sharpies or your Marks-a-Lots, those are fine. Welders tend to use paint pens. Nice thing about paint pens is that the chemicals in the paint pens will bond to just about any surface. Problem is it's a slow drying ink and it does break down the webbing, so that we don't allow. All right, any questions on harnesses? Okay, let's move on to C, connectors. Now, connectors, anything that you use to attach yourself to your anchor point. And when used for fall arrest, all of your connectors must incorporate a shock absorber. Now, these are examples of 6-foot shock absorbing lanyards. You can see the shock packs. This is also a 6-foot shock absorbing lanyard, but the shock absorber is built into this tubular webbing. This is also a connector. Does this have a shock absorber? It does, just not in the traditional sense. The way these devices work, there's a coil spring on this side, a drum, then on this side you got pawls, gear, and a clutch plate. So what happens when you take a fall, those pawls will grab onto that gear spins around that shaft, and that there's a clutch plate in there that's designed to absorb energy. If this doesn't absorb energy, guess what does become the energy absorber? We do, right? And we don't do very well at absorbing energy. You'll see this in action here in just a little bit. Do you have to inspect these prior to use? Absolutely. Everything that your life depends on needs to be inspected prior to use. Now, with these devices, you want to pull the cable all the way out. Reason being is oftentimes I've inspected these where the first few feet look great, but the last few feet look terrible because that's where it was rubbing on a sharp edge. Also, give them a pull test. These devices need to lock up if you're moving at 4.5 feet per second or faster. If you tug on the cable and it doesn't lock up, take it out of service. There's a problem with it. If you take a fall, they need to arrest your fall within 2 feet, within 24 inches. But if you're moving at 4.5 feet per second or faster, they need to lock up. Also, pull the plunger back. You want to inspect underneath the plunger. Oftentimes, this is where the cable gets kinked or bent, and this is where you begin to see some corrosion. And then check the hooks. Make sure that the impact indicators haven't been deployed. Do you ever use these devices where they're anchored down low at ground level? No? Okay. You want to be very careful in this type of environment tying off at foot level. Tying off at foot level in this environment is pretty dangerous because you're exposed to sharp edges. So you want to make sure that your tie-off points are at least at dorsal D-ring height or above. If you ever run into situations where you're tying off at foot level and you're exposed to sharp edges, you need to be using leading edge devices that will prevent from cutting. And self-retracting lifelines, unless otherwise designed to do so, are only meant for overhead use. Any questions on self-retracting lifelines? Okay, let's talk about lanyards. These also need to be inspected prior to use. So you're looking for cuts, burns, frays, chemical burns, UV degradation, check the stitching, check the webbing, check the labels. Labels have to be there, labels have to be legible. Now this is what we're doing to protect labels for you. So the labels are protected like so. When you're through with your inspection, make sure that the label's put away. Like so, good to go. Check your hooks. A test that I like to do with hooks is I like to open it up, let them close as slowly as possible. What happens if you have a hook that stays stuck in the open position? What do? Pardon?
Take it out of service.
Try cleaning it first though. A lot of times these things stick because they're dirty. What's a good cleaner for metal parts? Sure, WD-40. WD-40 works great. If you can use WD-40 though, cover up the web, spray the hook, work it in, dry it out really well. If it works, great. If it still sticks, now you take it out of service. And if you're going to take it out of service, cut it up and then throw it away. If you don't cut it up, somebody's going to go dumpster diving, they're going to find it, and then it's going to wind up back on this campus. All right, harnesses have many different types of D-rings. You have shoulder D-rings, chest D-ring, hip D-rings, thigh D-rings, back D-ring. What is the only D-ring on your harness that's rated for fall arrest? Your back D-ring, your dorsal D-ring. When using a shock absorbing lanyard, where does the shock absorber go? Closest to your back or closest to the anchor point? Closest to your back. Shock absorbers always go closest to your back. Okay, let's calculate total fall distance. I'm tied off to my dorsal D-ring, and I'm tied off to an anchor point equal in height to my dorsal D-ring. I fall. My free fall distance is 6 feet. My shock absorber can only deploy how many feet? Anybody know? 4 feet, right? So I got 6 plus 4 is 10. My body's going to form into the harness. That's going to give me another foot, so it's about 11 feet. Now the distance between my D-ring and my ankles is about 5 feet, so that's 16 feet. Let's give it a 2-foot safety buffer so I don't violate the number 1 rule of fall protection, which is don't hit the ground, right? 18 feet. 18 feet is the minimum clearance that you need when using a standard 6-foot shock absorbing lanyard tied off to an anchor point equal in height to your dorsal D-ring. Now you're probably asking yourselves, now wait a minute, Rick. Our policy says we got to tie off when we're working at or above how many feet? 4 feet. Washington State changed their policy. So anytime you're working at or above 4 feet, you have to be in some sort of a fall prevention system. So guardrails, handrails, the previous methods are better. But if that's not available, active fall arrest systems above 4 feet. Now given what I just told you, if you're using a 6-foot shock absorbing lanyard, and you're standing on a platform that's 8 feet off the ground, and you're tied off to an anchor point equal in height to dorsal D-ring, and you fall, you're hitting the ground, right? So what do you do to keep from hitting the ground and making somebody else do it? Doesn't count. What do you do? Raise your anchor point. Ideally, you should always raise your anchor point. Why? Because you reduce your free fall distance and you reduce the likelihood of contacting the lower level. What's another option? Sure, shorter lanyards. Most of us manufacturers make 3-footers, 4-footers. We make adjustable lanyards that adjust from 3 feet out to 6 feet. What's another option? A self-retracting lifeline. Why? Because these are designed to rest your fall within how many feet? 2 feet, right? Now, the nice thing is if you don't want to carry this big thing around, we do have new technology. So this is a 6-foot self-retracting lifeline. That'll mount directly to your back. So I got a special bracket here that'll mount to any harness. So press the 2 buttons, open it up like so. Just like that. Now, I got a 6-foot self-retracting lifeline. If I take a fall, there's my free fall distance. So your options are raise your anchor point, get a shorter lanyard, or use a self-retracting lifeline. All right, what do you say we do some drop tests? The first drop test we're gonna do, 1-inch web, no shock absorber. I've got a 220-pound steel weight, and I've got a load cell back here that's gonna give us the maximum arresting forces. Okay, 220 pounds falling 4 feet. What do you think the forces are gonna be? How much? 850 pounds. Anybody else? 1,500 pounds. Anybody else? All right, well, let's find out. All right, 220 pounds falling 4 feet. Watch the weight. Ready? 3, 2, 1. £4,333. Now, according to the regulations, the maximum allowable impact force placed on your body, according to OSHA, can be no more than 1,800 pounds. According to ANSI, no more than 900 pounds. Did we exceed 900? By a lot. With these kind of forces, dislocated hip, broken pelvic bone, compressed spine, internal hemorrhaging, major whiplash, head first fall, broken collarbone, dislocated shoulder. Just a really, really miserable day. Notice how the weight bounced several times? Every time that weight bounces, that's more and more damage to your body. Okay, the next drop test we're going to do is 1-inch web with the shock absorber, also a 4-foot drop. All right, what do you think the forces are going to be this time? Less. 50% less, so it's going to be about what, 2,100? Anybody else? 700? 650, all right, let's find out. All right, watch the weight, ready? 3, 2, 1. Ooh, 720 pounds. Ah, he was the closest. I might have to do something for him. All right, I can tell this lanyard was involved in a fall. I saw it. All right, originally, this is a 4-foot lanyard. This is your deceleration distance. This is your back D-ring. Your head's right about here. Your body's below this point. That's why we need 18 feet of clearance when using a standard 6-foot shock absorbing lanyard. Does that make sense? This is your shock absorber. If this tears all the way through, this is your backup strap. Pretty neat stuff. I'll pass this around so you guys can look at it. Okay, the last drop test we're going to do is with a self-retracting lifeline. Okay, watch the steel weight. Ready? 3, 2, 1. 806 pounds, but notice how it arrested the fall within 24 inches. In fact, we did much better than that. This is why self-retracting lifelines are ideal in situations where you got very little structure to ground clearance. So if you're working in areas and you don't have 18 feet of clearance between your anchor point and the structure below, then a self-retracting lifeline is the ideal way to go. Now, the thing to keep in mind with lanyards, the clearance charts that we give you are based off of the anchor point. So the measurement goes from the anchor point. So it's 18 feet from the anchor point, not the structure that you're standing on. With self-retracting lifelines, the clearance charts that we give you are from the structure that you're standing on. So for instance, if this self-retracting lifeline is anchored 5 feet above me and I fall, it's supposed to arrest my fall within how many feet? 2 feet, right? If I raise that self-retracting lifeline up another 10 feet and I fall, it arrests my fall within how many feet? Still 2 feet, right? So, self-retracting lifelines, clearance charts are from the structure that you're standing on. Lanyards are measured from the anchor point. Very important. Okay, the last thing we're going to talk about is how to properly put on a harness. Once you've inspected your harness and you've determined that it's okay to put on, the first thing you'll want to do is take all sharp objects out of your pockets. Keys, knives, Leathermans, fingernail clippers, emery boards, anything that's sharp, take them out of your pockets. Chest buckle goes right at your sternum. Not too high, not too low. If it goes too low and you take a header, you run the risk of falling out of the harness. If it's too high, the buckle could come up, hit you in the jaw. Leg straps. This is what I see on most work sites. Loose leg straps. The problem with loose leg straps is, number one, what's the maximum allowable free fall distance according to the regulations? 6 feet, right? What have I just done? I've added 8 to 12 inches of additional free fall, which means I'm generating that much more momentum, which means that the likelihood of these straps winding up where I don't want them to, quite high, which means adios amigos. You guys know what I'm talking about, right? Guess what else I don't see? Where's this chest strap gonna wind up? Right in my jaw, right? Because I'm gonna be looking down to see what I'm gonna hit. And guess what? That chest strap's gonna come right up and hit me right in the jaw. So, one of the things that we tell you to do, this particular harness has a tool belt, so I can wear this any way I want. Adjust the leg straps so that they're snug. So, the rule of thumb is if I can fit my hands in flat, great. If I can make a fist, the leg straps are too loose. Get your loose ends out of the way. Adjust your torso so that it's snug. This is way too loose. So the way this gets adjusted, this actually has revolver torso adjusters. Nice and easy to put on, just like that. Now I'm wearing my harness correctly. The back D-ring, right between the shoulder blades. The subpelvic strap, underneath your butt. This is the strongest part of your body. This is a primary impact zone. Chest and shoulders are your secondary impact zone. Now you've fallen and you're suspended in your harness. How long do you think you can be suspended in your harness and live? I don't know, throw me some beers, I'll be all right. Depending on physical conditioning, less than 15 minutes. Reason being is you got 2 major arteries on the inside of your legs. They're called your femoral arteries. So what's happening while you're suspended, you start building up toxins inside those arteries. What happens to blood when blood stops? Clots, right? What happens when you relieve that pressure? Where do those clots go? Your heart, your lungs, your brain. I'm not a doctor, but I can tell you this. Any one of those destinations is a bad destination. So one of the things that we train people to do while you're suspended is to flex your muscles. And no, I don't mean flex your leg muscles or try and get yourself into a cradle position. You do that, allows the arteries to open up, allows the blood flow to continue. Now, the other thing we have too is these devices here. They're called suspension trauma straps. And all you do in the event of a fall is unzip the pouches. You got multiple loops on one side and a hook on the other. And all you do while you're suspended, hook them together like so. Just like that. Get your feet inside that cradle. And all you do is simply stand up. Now I've increased my suspension time. Now I can wait for you guys to come back from break to come back and rescue me, which might be a while. Which brings me to my last point, A, B, C, and D, descent and rescue. You need to rescue somebody as quickly and as safely as possible. Now when it comes to rescue, simple solutions are great solutions. If the person's able to do so and you get a ladder underneath that person, let them self-rescue that way, it's a good solution. If you've got a lift on site, get that basket underneath that person, rescue them that way, also a good solution. If dialing 911 is part of your rescue plan, number one, realize that they may not respond within 15 minutes. Number two, you better let them know what kind of hazards they're going to encounter. So if it's high angle rescue, let them know it's high angle rescue. If it's confined space, let them know it's confined space. That way they can send out the appropriate team with the appropriate equipment to perform the necessary task. All right, the 4 things I want you to take away from this are A, B, C, and D's. Anchorages have to be rated to how many pounds? 5,000 pounds. And the structure that you're attaching them to also has to be rated to 5,000 pounds. And we know that because it'll support the weight of your what? Full-size pickup truck. Harnesses need to be inspected when? Prior to each use and at least annually by a competent person. A competent person is going to look for things that you tend to overlook. Your connectors, when used for fall arrest, must incorporate a shock absorber, and we got to get those forces to less than how many pounds? 900 pounds. In fact, you saw we did better than that. And also make sure that the hooks are compatible with the anchors that you're tying off to. And lastly, descent and rescue. You need to rescue somebody as quickly and as safely as possible because 15 minutes is a very long time to be suspended in your harness.